Have you ever actually stopped to wonder if we could survive on a planet where the sky is literally pink and the ground is nothing but red, frozen dust? Welcome to This Explainer. Today, we're exploring a reality that sounds like a wild sci-fi dream, but trust me, it's actually a nightmare of extreme engineering. Getting to Mars? Honestly, that's the easy part. Staying alive on a planet that is actively trying to kill you every single second? That's a completely different story. So let's dive right in and look at exactly what it takes to architect a home on an alien world. Step outside and your blood will boil while you freeze to death. Just let that sink in for a second. This isn't some Hollywood exaggeration. It's the terrifying physical reality of the Martian surface. If you were to step outside your habitat without a pressurized suit, the absolute lack of atmospheric pressure would cause the liquids in your body to literally boil. And the crazy part? That would happen even as the ambient temperature froze you completely solid. We aren't just talking about building houses here. We're talking about building absolute fortresses against an environment that is fundamentally hostile to human biology.
Chapter 1: The Hostile Martian Frontier.
We're facing 7 deadly challenges standing between humanity and a thriving Martian colony, and these obstacles represent the most monumental human expedition ever conceived. Honestly, it makes building the Great Pyramids look like playing with Legos. To truly grasp the stakes here, think about the number 55 million. 55 million kilometers. That's the distance our rovers have already traveled just to reach the Red Planet, and it brilliantly illustrates the sheer terrifying scale of our isolation. If something goes wrong out there, there's no quick rescue mission. You are 55 million kilometers away from the nearest hospital, the nearest hardware store, and literally the nearest breath of fresh air.
And the moment you arrive, you're immediately facing the first and arguably the most invisible killer: radiation. See, Earth provides us with these incredible natural defenses. We've got a nice, thick, comforting atmosphere and a massive magnetic field shielding us from the chaos of space. Mars, on the other hand, is completely defenseless. It has this whisper-thin atmosphere and absolutely zero magnetic field. What does that mean for us? It means cosmic rays are continuously bombarding the surface, ready to quite literally shred our DNA. Chapter 2: Radiation and Extreme Cold.
So, the big question is, how do we actually protect ourselves from this invisible killer from above, not to mention the freezing nightmare waiting below? Well, the solution to our radiation problem is what we call the deep hole strategy. Here on Earth, engineers have successfully dug 12 kilometers straight down into our own planet, and we know that at just 1,000 feet deep, structures are practically immune to massive surface blasts. So to survive on Mars, our very first homes, they definitely won't be those shining glass domes you see in movies. No way. They're likely going to be built entirely underground, or at least covered in meters of Martian soil, utilizing these deep hole digging techniques just to keep our cellular structure intact. But once we're safely underground, we have to deal with the temperature. Minus 60 degrees Celsius. That is the average temperature on Mars. We often picture alien deserts as these sweltering, hot landscapes, but Mars is a fundamentally freezing world. If your heating systems fail out there, a Martian base doesn't just get a little chilly, it becomes a literal frozen tomb in a matter of minutes. To truly understand the level of absolute thermal control we need for this, we have to look back at an incredible event in Earth's history. Picture this. It's 1959, and an expedition successfully moved a 3,000-kilogram block of ice, 8,500 kilometers, straight across the blistering 50 degrees Celsius heat of the Sahara Desert. How on earth did they pull that off? They used highly advanced special glass wool insulation. To survive our Martian future, we literally have to take the genius of that 1959 ice block journey and multiply it exponentially. We're talking about unprecedented thermal control just to keep humans alive.
Chapter 3: Dust Storms and Oxygen Loss.
Now, keeping warm and shielding from radiation, that's really only half the battle. We also face the compounding threats of intense environmental assaults mixed with catastrophic mechanical failures. I like to call this the Titanic mistake on Mars. Think about it. When the Titanic sank, it was this awful cascade of unheeded warnings and environmental unpreparedness. On Mars, we'll face global dust storms that can last for months on end, completely blocking out the sun. If our colony relies solely on solar power without a rock-solid plan B, we're doomed to repeat history. And just like the microscopic structural failures of the Titanic, where soft iron rivets just gave way under immense pressure, one tiny, overlooked oversight in a Martian storm means total cascading collapse. Which brings us directly to the oxygen crisis. The absolutely crucial point here is this. Surviving requires a perfectly sealed loop, period. Think of the deepest mines in Africa, right? Temperatures down there reach 66 degrees Celsius, requiring massive, utterly flawless ventilation systems just to keep the workers breathing. A Mars colony requires that exact same level of engineering marvel. It demands absolute perfection, zero structural flaws. Because out there, the suffocating Martian vacuum is constantly pulling at you, just waiting for the chance to rip the atmosphere right out of our habitats. Chapter 4: The Nightmare of Construction. So, assuming we can actually engineer the perfect, warm, breathable underground bunker, how in the world do we actually build and supply this futuristic fortress? Well, let's compare historical Earth feats with what's required for Mars. Ancient engineers built the Great Pyramids by moving 50-ton stones, each one weighing as much as 3 whole passenger buses, and they used an army of thousands and riverboats to do it. But on Mars, we won't have an army, and we certainly don't have rivers. Instead, we'll likely have to adopt methods like Dubai's Dynamic Tower project, where entire floors are prefabricated in factories and then just assembled on site. This method saves 30% on labor and costs, which is honestly absolutely vital when every single gram of material has to be rocketed into space. And the logistics of rocketing those materials into space, they're staggering. Remember that ice block we talked about moving across Africa? It took them 28 days to cross a single continent. Now, to send a single resupply ship to Mars takes 7 to 9 agonizing months. That is an absolute logistical nightmare. You literally cannot wait 7 months for a spare part if your water filtration system breaks down. Achieving true independence from Earth requires some truly extraordinary innovation. We need transport speeds far exceeding Dubai's planned 1,223 km/h Hyperloop just to make the trip somewhat practical. But even more importantly, we need complete water and food recycling. Take India's $2 billion Antilia house as an example. It requires a dedicated staff of 600 people just to keep its complex systems running. Until our Martian habitats can recycle every single drop of water and grow all their own food with perfectly self-sustaining ecosystems, we remain terrifyingly dependent on our home planet. But let's say we do solve the engineering. We beat the cold, the radiation, the dust, and the logistics. All of that brings us to the ultimate, fragile unknown. Can the human mind actually survive Mars? Chapter 5: The Human Breaking Point. Beyond all those physical threats we just went through, the psychological toll of being trapped in a cramped, dark, and dangerous pod for years on end, well, it simply cannot be overstated. This is the ultimate test. It's not just about emotional endurance, it's about maintaining extreme cognitive ability under immense pressure. Surviving catastrophic failures millions of miles from help requires Einstein-level logic. We're talking about needing individuals who possess a literal superconnection between their brain hemispheres, allowing them to imagine and solve incredibly complex physics problems without even reaching for a pen and paper. When those alarms go off and the automated systems fail, human genius is quite literally the only thing standing between the crew and the freezing Martian vacuum. Building a life on Mars is hands down the highest hurdle humanity has ever faced. If we fail even one of these 7 challenges, you really have to wonder, will our Martian colony become a testament to human genius? Or will it merely become a museum of the future, trapped forever in frozen red dust, much like the mummies of Egypt are a museum of the past? It's a beautifully fascinating question and one we absolutely have to answer if we ever hope to call 2 planets home. Thank you so much for joining me on this explainer. Keep wondering, and I'll see you next time.